So this is Charlie, and let's go ahead and continue our discussion of unit testing. So in the previous discussion of unit testing, we just got you through the basics, gave you an overview of how unit testing works. So let's dig in now and see a little bit more details. I've broken this out into a separate deck because there's a good deal of material to cover, and you can see here the bit.ly. It's modules.js would be your bit.ly URL. So you just do the standard HTTP, then bit.ly, then modules.js. You don't really need that while you're watching the video, but you might want to have it later so you can get at the deck. So one of the kind of basic foundations of this particular course is that the building blocks of good JavaScript code are unit tests, modules, and objects. So when you sit down to write any code, your first question should be is where are my tests and what are my tests? Your second one should be what modules am I using? And the third one should be what objects do I export from those modules? And we usually only export one object per module, okay? Now there might be cases where particularly when you're building a set of utilities, you might export a series of functions rather than a single object from a module. And we'll talk about, the point of this deck is to make all this clear, to talk about the relationship between unit tests, modules, and objects, and how you define your unit tests, how you build modules, and how you create your objects. So here's just sort of an overview of all those major points. We're going to look at unit testing. We're going to look at creating Node.js modules, okay? Now, I'm going to learn how to export code from the modules with module.exports and import modules with require. We're going to learn how to build JavaScript objects and build JavaScript functions that are easy to test and that are structured correctly. And we're going to have a place where you can find the example code that we're talking about here. And of course, you pull it from the JS objects repository. And if you you should always do a git pull, even if you have already pulled the repository, because there may be updates. In this case, there are updates that are quite recent to this code if you're following this along on in more or less real time. So modules, what are modules? Well, modules are a way to do two things, to create distinct places where you can put your code and to protect the code that's in that module from the global namespace, all right? And there's many different ways to build modules in JavaScript, and that's one of the more confusing aspects of JavaScript is that there are so many different ways to build modules. On the server side, fortunately, things are fairly simple. When we're writing Node.js code on the server, we're not showing our code in a browser, or we're writing the server side of a program which has code in a browser, then it's fairly simple. You use require, and we'll show how to do that. And you usually, in the code that you're writing, you have an export statement at the bottom or modules.exports. They're synonymous. It doesn't matter whether you write modules.exports or whether you write exports. And then when you want to use that code in another module, you use require to link in the code that you exported from the previous module. Okay. On the client side, there's at least three very common ways to do it. One is to use something called the modular pattern, which one of its benefits is that once you understand it, it's clean, it's beautiful, it's all self-contained. You're not relying on any other tools. It's just using the JavaScript language, and I like that fact about it. Another very common way to build modules is with require.js. And another very common way to do it is with AngularJS, which sort of builds require.js into it itself. There are other ways to do this, but one way or another, you're going to build modules. And right now, this video is focused on server-side only, building Node.js modules with require. Okay, so in the simplest form, your program has to be divided up into two things, your test and your actual program. So in we're in our simple examples that we're running, there's going to be a directory called test, and there's going to be a directory called source. In the test directory are your tests, and the source directory is your source. Now, in a bigger program, you might have a source directory, but inside of the source directory, there might be multiple folders and multiple files. We will, in fact, have multiple files in the example we look at, but only one directory. Mocha tests expect the tests to be in a directory called test with a small t. I just like the convention of having directories with big letters, okay, with a capital T. So we need to tell Mocha where our tests are. We can't just run type Mocha and have it expected to find the tests automatically, as it would if we had a small t for our test directory. So instead we write Mocha test, just pass in that parameter just like that, and then Mocha will know to look in the test directory for your tests. So here's a simple example of what we could do with code that was divided up into this code in the test directory, this code in the source directory. So here's our program. It's a very simple program, and it exports a single function, and that function is called get1. So we use exports.get1 equals get1. We could also write modules.exports.get1, but this is what everybody does. Well, they both are used a lot, but this is what we'll probably do more often. Then in order, so here's our module. It's one file in JavaScript. There's a one-to-one in Node.js JavaScript. There's a one-to-one correspondence between modules and files. A module is a file. But the big thing that a module is doing for you is protecting the global namespace, okay? And in other words, it doesn't let anything leak out from that module into the global namespace. If you want to see the global namespace for some reason, console.log open paren global, close paren, okay? It's all in that one variable and you can see it. Okay, now var, here we've created this module. We've put it in a file called numbers.js. And then here where we want to use it in our test, we're in the test directory. So we go back to the root, relative path, back to the root. Then we open source and we go into the source folder, and then we get numbers.js, and we call require to do that. So we export things from a module with exports, we import them with require, okay? So here we are importing the numbers file with require. And then now we can run our tests, and down here we can write numbers get1 in order to call the get1 function, and our test expects get1 to equal 1. So that's our basic pattern for how you go ahead and do things. Now, here's two different ways to export a single object, okay? So in the previous example, we were exporting a function. Now let's look at this example where we're exporting an object. So see the difference here? Here we write function, we're exporting that function. Here we're exporting an object, and there's two different ways to do it. We write either module.exports, and then we directly assign it to the object. Here's the object here. Or we could name the object that we want to export, where we go module.exports.numbers, and then we export our object. And in the first case, in this one, we would require, and maybe we would have source in here. I'm just out of room. So we're just getting our numbers. We're importing numbers, and we get it in a variable called in, and then we go in.get1. That's how we would import. That's how we would require this particular module. Now this one, where we've named the object that we're exporting, you would go in, we require numbers.js, and then we go in.numbers. That's the name of the object that we want to get, okay? Now, an example of this is here. The require object we get chai out of here. We get the package chai with require, and then we pull out the expect object from it. And that implies that there's more than one object in here. And when we tend to use this kind of syntax where we're doing numbers, that usually means that that particular module is exporting more than one object from it. And we kind of have a rule, let's only export one object per module. The rule is obviously not hard and fast. Okay, here's how we would export two functions in a single object like this. So we're doing module exports, we're creating an object, and we're exporting two functions. You can see they're separated with a comma, and the name of the function is separated from the implementation by the colon. So we've got our key value pair. The key is the name of the function. The value is the definition for the function itself. Here, now we're back talking about functions again. And let's go ahead. Best for use with utility functions that are totally unrelated to one another is this syntax. We've got function get1, we've got function get2, and now we can export get1 equals get1 exports get2. Now this particular module exports two functions, one called get1, one called get2. This type of syntax is usually best for situations in which you've got a bunch of utilities put together, okay? So when you've got a bunch of utilities that you want to work on, then the best way to put them into a single module is with this technique. There's get1 and get2 have nothing to do with each other. They don't share any information. They don't have anything. This is a kind of a typical way to do that. If you're getting into a more complex structure, then you want to export an object out of there, not a series of individual functions. Okay, here is a way to start exporting a function object out of a module. And here what we're doing, we are using new. I'm missing a semicolon there, forgive me. We're using new to instantiate the numbers object. So that's why we have a capital N here, because this object, the capital N on a function object name means you must use new to use it correctly. And because we're using this inside of here, we've got to call new to make this work right. If we took away the new, this export wouldn't work right. And we're naming, in this particular case, we're naming this particular thing numbers. It would still work if we took away the name, but we just call it with different syntax on the other end when we require it. And here we can see we do this.get1, this.get2. When we use this syntax, then each instance of the numbers object that we create with new will have its own unique copy of the get1 method, okay? If, however, we use this syntax where we create a function, then we use the prototype property to add a get1 function and add a get2 function. This is a syntax, numbers.prototype.get1 equals function, numbers.prototype.get2 equals function, and then we export new numbers. Here I've got my semicolon, but I don't have my open parens, close parens. I'm sorry, I just don't understand what my problem is here. Forgive me for not getting that right the first time. Okay, so here's where numbers.prototype, we're using the prototype to do it. The difference between this example and this example is that in this example, no matter how many times you create, no matter how many instances of the numbers object you create, you're only going to have one instance of the get1. All of those instances of numbers will share this single copy of get1. This is the preferred way to do it. It's very similar to the way, it's like we're one step away from implementing the modular pattern on the client side. And this is the way we do it. It gives us the most ability to have information hiding, to have static versus non-static methods to do all the different types of things that have hidden private functions, public functions. These are public functions, of course, and this is the preferred way for us to make objects. But you'll see this technique too, which is totally reasonable. And of course, you'll see this technique quite a bit too. That's another very reasonable way to make objects. But our preferred way, when in doubt in the program, make it like this, or use the modular pattern on the client side, or require JS, which we'll get into later. Okay, let's go ahead and watch it all in action for a little bit here. And we're in our mock tests. We're going to write npm test, and we're going to run some tests. And now, right now, let's look at our tests for just a second and see what it is we've actually got here. Here's one called object get1. It exports get1 and it returns get1. Now, over here in our tests, we have code that requires the object get1 and that calls object get1.get1. Now, right now we're running a bunch of tests. If we do this dot only thing here, then when we run this down here, when we run our tests, we'll only run that one test. Did you see the way I did that? I put dot only here so that all the other tests didn't run. Remember before, a bunch of tests got run. We wanted to focus on one test. That way you can say, just run this one test by doing that. So what we've got here in our structure for these particular tests, first we bring in chai, then we get the expect object out of chai, then we describe a kind of general set of module tests, and then inside of here we've got a set of tests which tests just the get1 object. And this is a good pattern to go ahead and say, I want to test only inside of this particular subsuite here, we're going to test only the object get1. So I'm going way out of my way here to have it put in a before section where I'm going to load object get1. So before these two tests run is what this syntax means. Let's go get object get1. And object get1 returns 1. And then over here, we're going to we're going to run that one test. Now, over here, I have an alternate spec. And here's another way to structure things, which frankly, I think is probably preferred. But right now, I wanted to totally delineate each test from the other. Here, I load all of my modules up on the top, and then I use them down here. While in the numbers spec, I'm explicitly loading them only for this set of tests. It's a scoping issue. And here I'm just trying to say, inside of this object, we're only testing object get. Inside of this suite, we're only testing object get1. Inside of this suite, we're only testing object numbers. So what does object numbers look like? Here's a case where we're exporting two functions. We're exporting an object that contains two different functions. And what does that test look like? First, we get the object number source code, and then we call get1, and then we call get2, and make sure that they're tested correctly. Now, suppose we just want to run unit test object numbers. So we only want to run this particular sub-object from the ones that we have. We can write mocha -- grep then paste in, tell it to go to the test directory. And now you can see it only runs the object numbers test, only those two that are part of this particular, it's ignoring this suite, it's ignoring this one down here, it's running only this one, and it ran those two tests. Now here's the unit test function utilities, excuse me, It's a name issue here. So this one's unit test function utilities, okay? And let's go ahead and run it. So we'll come down here. And when we paste it in, it only runs the function utility tests. And the function utilities, I think you already can guess what that's like. Notice I'm using a slightly different syntax than I used in the slides. I'm doing exports get 1 equals function, exports get 2 equals function. While in the slides, the way I did that was to do it this way. I define function 1, define function 2, and then I do get 1, I do get 2. And down here, I'm exporting each one separately. 6 of one, half dozen of the other. And as you saw, both tests, we call function utilities get 1, it's equal to 1. Then the final one that we're going to look at here is function numbers. And this one, I create a numbers constructor object is what this is called when you create it like this. And then we use the prototype property to add on 2 methods because it's a dynamic language. We can change the object after we created it, and we'll add get 1, we'll add get 2, and we call new numbers on it in order to do it. If you wanted to check the other syntax, you could uncomment this code down here, and this uses the get technique. Works exactly. We don't have to change our tests at all. It's 2 ways to do the same thing, but this is the preferred way here. And again, if we want to take a look at our tests, then we go ahead and we grab this string and we come down here to the command line and paste it in. And now you can see we're running those 2 tests and they work. Now remember, this one's all your on JS objects, so you can see this. And you can run all these tests as you prefer. I do provide 2 little scripts for you. One of them, why don't we look at them inside the IDE? One of them is called run modules, alternate modules. This will run only the alternate modules tests because we're using grep to define it. And this one uses only the module tests. So if we type /run module tests, will only run the module tests. Or if we run the alternate module tests, we only run the alternate module tests. Or if we write npm test, then we run them both. All right, awfully long video, but I think that we just needed that much space and that much time to cover all these issues. What was my little summary slide here? Filter with grep and only as needed. Remember this only to run only one at a time. Oh, there's integration with Webstore. There was one more thing. That's why we write these summary guys. You can come up here to the run menu and go to your edit configurations and use the plus symbol to create a new set of unit tests and say that you want to point at where you installed Mocha and you've installed it at the same place. Your place will be called BC user rather than Charlie Calvert, but that's where Mocha is placed. And then say what tests it is you want to run, have your path to where your tests are. And now you've configured this run configuration. And then once the run configuration is there, you can just run it. And now all your tests run inside the IDE, which is very nice, so you can see them. And you can click on them and it'll take you right to the particular test in your code that's being run. If you click on this little button up here, then when you make changes, your tests will get run. So I made a change, and then we wait a second, and now you can see the tests run with the error in it showing up right inside the IDE, and then we'll change it again, and then you wait a second, now the tests all pass, right? Very convenient to have this integration with the WebStorm IDE. Okay, integration with the WebStorm modules. On the server side, we use require, and some later video we'll talk about require.js, AngularJS, and the modular pattern. And there are other ways to build modules in JavaScript other than these, but these are the big ones that we're going to use. And then we talked about creating objects, creating standard JavaScript objects, and creating function objects with new. And we talked specifically about the fact that we like to use a prototype property to create our functions. So now the video is really long, but it is finished. And this is obviously a foundational video for our course. This is describing a lot of the way we're going to build our programs. Most important thing, unit test everything. Always work with modules. Make sure you're creating your objects correctly, particularly use function objects with new function objects and prototypes. Thanks now. Bye. Have fun with this. Always have fun, right? Just go take a walk if you're not having fun. All right. Bye now.